so I'm going to put learning targets 6.15 and 6.16 together because they kind of run perfectly together. Learning target 6.15 is I can define Le Chatelier's principle, and 6.16 is I can predict how a reaction will shift in response to a change in temperature, concentration, or pressure. Okay. Le Chatelier's principle first states that reactions will attempt to find equilibrium when temperature, pressure, and concentration are changed. So Le Chatelier's principle basically says that if a system that's at equilibrium is stressed, then it's going to shift in the direction that will relieve the stress, right? They will attempt to find equilibrium again. They shift away from the stress to relieve the stress. And now what does that mean for us? Okay. So what that means, not for me because I already went to high school, but what it means for you is if we tell you that there's a shift in temperature, or there's a change in temperature, concentration, or pressure, you're going to be able to explain how that reaction is going to react in order to sort of find the balance again. Okay, so there are three types of stress: temperature, concentration, or pressure. What I'm going to use to demonstrate this to you is this idea of a seesaw. All right, so a seesaw, in case you guys don't know, looks like this. Here's my seesaw, right? Seesaw can look like this, or a seesaw can look like this, right? Where's the heavier person? The heavier person is on the side that's lower, and the not so heavy person is on this side. Okay. Now, imagine if you're on a seesaw, where would you have to shift, or where would you have to move in order to bring it back to its balanced state? So seesaws all want to look like this. This guy would probably have to move that way, to the right. This guy would have to move to the left. Now, the reason I say we should use seesaws is because if you imagine this to be my reactants and this to be my products, now we know which way you have to shift in response to this guy or your stress. Okay, so we're going to actually take a look at what this means for us. Okay, so let's go ahead and start by thinking about temperature. Okay, you should actually think of temperature the same as temperature and concentration. You can treat them the same in terms of solving these types of questions. I'm not going to go into the theory of it. If you do need to know about theory, please ask your science teacher. Okay, temperature and concentration. So, imagine the seesaw, right? If you increase your reactants, what's a better way to describe this? Okay, so for temperature, you actually don't look at temperature, right? You look at heat. Okay. When you see a question that talks about heat, so you might see something like energy plus something yields something plus something, or you might see something plus something yields blank plus 53 kJ. Right? If you see any one of these things, know that you're talking about heat. Here's heat and here's heat. Okay, you can consider this as your stress, right? So for this top one, it would look a little bit like this. So if I increase the heat, right, you're going to increase on the side with the heat. Or sorry, if you increase in temperature, you're going to increase on the side with the heat. So if I'm looking at this problem or this question, your heat or energy is on the left, so this side of my really cool seesaw is going to go down, right? So here's my stress. So it's going to look like this diagram. Now, how do you react, or how do you shift, right, to go back to being in equilibrium? Well, if this is your stress, you're going to want to shift this way to your right, right? So if that were the case, you would shift to your right. In this bottom one, right, if I add the stress is 53 kJ. If I increase temperature, here's the part I'm sitting on, I want to shift to the left to go back to being balanced. Okay. Now, the tricky part is when they say temperature is cooled. Okay. So if I decrease temperature in this first problem with energy on the left, if you decrease it, what are you doing with the stress? Are you adding heat to decrease temperature, or are you decreasing it? Well, I mean, you're getting rid of it, right? So your stress is actually lighter on the side, right? So where would you have to move to balance it out? You would actually have to move this way, right? So you would shift to the left in this case if the temperature was decreased, right? In the second problem, if temperature is decreased, right? Temperature's on the right. If you decrease the temperature, less energy, you're going to have to shift to the right to sort of balance it back out. The idea behind this is you want to create more heat on this side to sort of bring the temperature back to normal. You want to create more energy on this side to bring the temperature back to normal. Okay. As I just said, concentration works the same way. The word concentration means amount. Right, so the amount that you have. So in this case, right, you can have amount here, you can have amount here. You can change the concentration of any of these things. Again, just imagine, where's the stress? If the stress is here, then you're going to shift that way. If the stress is up this way, you're going to shift that way, right? So use those pencils is very helpful. Now, that's for temperature and concentration, the seesaw analogy. Use it, it's handy, it works. However, when it comes to pressure, everything is not so hunky-dory. Remember, pressure only affects gases. Right, it is basically however many times a gas molecule will hit up against a surface, right? So pressure only affects gases. When you think of gases, think of moles. Okay. So if you were to increase pressure, if you increase the pressure, you're going to shift to the side with less moles. If you decrease pressure, you shift to the side with more moles. Okay, so imagine, actually that's really the key here. If you don't retain anything else from this, remember this part, but we'll try. Okay, so more moles, less moles. The way you find moles is look at the coefficients. Okay, so let's imagine this is 2 rooms connected by a hallway, right? Now, if you increase pressure, and there's 3 of you here, you increase pressure, you're bringing the sides down. You're not going to, if you're this person, you're not going to want to be in this room with 2 other people. You're going to want to be in the room that only has another person here that's sort of chilling out, right? Or if I make it a little more obvious, and you're still this person, you don't want to be in this room when pressure is increased, right? You're actually going to want to mosey on over to this room because there's only one person. That person's not going to bother you, okay? So if you increase pressure, you will shift to the side that has less moles. Now, if you decrease pressure, you're actually going to shift to the side with more moles. I can't think of a better analogy than a party. Who wants to be this kid at the party? Nobody. You want to go to where the party's at. So if you open up the space, you want to be in a place with more people. So if you decrease pressure or increase the volume, decrease volume. So if you increase the space, you want to have more people with you, right? You don't want to be by yourself. I mean, maybe you do, but let's pretend you don't, right? Increase volume, decrease pressure, go to the side with more moles. Okay. So you'll have plenty of time and plenty of practice on this, but let's do one quick practice question. The question is, as follows. What will happen if the following reaction is at equilibrium and more H2OG is added? Okay, so the first thing I always ask myself when I see a question like this is, am I talking about temperature? Am I talking about concentration? Am I talking about pressure? Well, we're talking about this. Does this say anything about temperature? No. Gas, okay, it might be pressure. Yeah. And concentration. Oh, well, it can't be pressure, even though it's a gas, because it's not talking about decreasing or increasing pressure or volume, right? So it's not pressure. We're talking about concentration. You're adding more amounts of H2O gas. Okay, so if we're doing concentration, we have to think of the seesaw. All right. So here's how you use the seesaw. Actually, this should be more aligned here. Okay. Basically, your seesaw is here. Your reactants are on this side. Your products are on this side. Now, you start off at a nice balance. If you add more H2O, where's H2O? It's on the left or on the right? It's on the right. Okay. You add H2O. This side gets heavier. Which way do you need to shift in order to bring it back to its happy balanced state? Gotta shift to the left. Shift left. Okay. So let's see if we can find any of these that will fit that. The forward reaction rate will increase. Forward is that way. No, it shifts left. Okay, not that. The reverse reaction will decrease. So going this way, this slowed down. No, it shifts left, so it's going to increase. Nope. The reverse reaction will increase. That's your correct answer, right? It's going to shift to the left, and it's going to go faster because you have a lot of this. So your system's like, whoa, too much on this side. Let me go ahead and use some of this up by making more H2 and O2, right? The reaction will not have to stay the same because if you change something in an equilibrium reaction, it will change or shift to fix the issue.